You won't believe how far AI has gone. Israel is now guiding its advanced missile technology with systems smarter than anyone expected. Hello everyone, welcome back to the channel. Today we're exploring a topic that surprises many people: how Israel uses artificial intelligence to manage and guide some of its most advanced defensive missile technologies. This isn't about dramatic action or tension. It's about how a country uses smart systems to improve accuracy, reduce human error, and make fast decisions when timing matters. AI in this field has grown from simple tracking tools into systems that learn patterns, predict movement, and adjust in real time. Engineers describe these platforms as decision helpers rather than replacements for human control. The core idea is simple: use technology to process information faster than a person can, especially when sensors are collecting massive amounts of data at once. Israel has invested in radar networks, secure communication links, and machine learning models that analyze signals quickly. These tools help operators understand the environment, track sources, and choose the right response with more confidence. Today's video will break down how these AI systems work across different layers, from detection to tracking to guidance, without going into dramatic language. Instead, we'll keep it clear, calm, and informative, showing how technology continues to reshape modern security systems in an increasingly digital world. AI inside Israel's missile-related platforms starts long before any launch sequence. The foundation is data, massive streams of radar returns, satellite visuals, and real-time sensor feedback. Traditional systems struggle with this volume, but AI models can filter, categorize, and highlight important information within milliseconds. This creates a more reliable picture of what's happening in the surrounding environment. Engineers call it a smart awareness layer. Instead of simply detecting objects, the AI analyzes size, speed, direction, and even pattern consistency. If something behaves differently from expected patterns, the system flags it instantly. Human operators still make key decisions, but now they are supported by clearer, faster insights. Another important element is prediction. Machine learning tools are trained on countless past scenarios, giving them the ability to estimate where an object might move next. This predictive assistance helps teams prepare faster and avoid delays that could lead to mistakes. The system's goal is not to replace humans, but to reduce pressure by turning complex sensor data into clear, organized information. This early AI stage forms the backbone of Israel's defensive technologies, showing how digital tools can transform decision-making without adding drama or complexity. Once the awareness layer identifies and organizes information, Israel's AI systems move to the tracking stage. Tracking may sound simple, but in reality, objects can change direction, speed up, slow down, or disappear behind terrain. Without advanced assistance, operators can easily lose accuracy. AI solves this by maintaining continuous locking logic using adaptive algorithms. These algorithms learn how fast an object typically travels and how it behaves under different conditions. Even if the object makes unexpected adjustments, the AI recalculates almost instantly. This keeps the tracking smooth and reliable. Multiple sensors, radar, electro-optical cameras, and infrared systems feed the AI simultaneously. It cross-checks all inputs to verify consistency, limiting false data. If one sensor receives unclear information, others compensate. This multi-sensor fusion is one of the biggest strengths of Israel's AI-supported systems. The tracking doesn't just follow coordinates, it builds a dynamic model of the object's movement and future path. Operators monitor this model on screens that simplify everything into clean visuals. The result is a system that supports decision makers with precise, updated information, ensuring they can act with confidence. This careful, organized tracking is a key part of Israel's modern security technology. Next comes decision assistance, one of the most important roles of AI in Israel's missile-related platforms. Human operators stay fully in control, but AI suggests possible responses based on the situation, timing, and available systems. These suggestions are not commands, they are options. This reduces stress and helps operators focus on verifying information instead of rushing calculations. The AI uses rule-based logic mixed with learned behavior from past data. If the system recognizes a situation similar to previous events, it highlights recommended actions. It may suggest which system is most suitable, what timing is ideal, and which angle provides the best effect. Everything is displayed clearly without complicated menus. Operators can choose to follow or ignore the suggestions. The goal is not automation, it's support. By offering organized choices, AI prevents delays that often occur when people have to manually process complex information. Israel's engineers emphasize reliability and transparency, meaning the AI must show why it recommends something. This helps prevent blind trust and ensures every action remains deliberate. This stage shows how AI can improve clarity, reduce confusion, and enhance safety in high-tech environments without removing human oversight. When a defensive missile system is activated, AI also helps manage the guidance process. Traditional systems rely heavily on pre-programmed instructions, but modern AI adds adaptability. If the situation changes, the AI quickly recalculates the best path. This flexibility is particularly important when objects move unpredictably or when environmental conditions shift. AI guidance doesn't mean full automation. Human operators still supervise every step. However, the AI handles complex math, trajectory curves, timing windows, and speed coordination that would take humans too long to compute manually. Guidance models in Israel's systems are trained using simulations that include thousands of potential paths. This training allows them to adjust smoothly, avoiding outdated assumptions. The AI also works with real-time sensor updates, meaning the guidance isn't fixed. It evolves as the situation evolves. These guidance improvements aren't about aggression, they're about precision, safety, and reducing miscalculations. By minimizing errors, the system helps prevent unnecessary escalation and improves overall stability. Israel's engineers highlight that the goal is to make guidance cleaner, smarter, and safer while maintaining strict operator control. This deliberate balance between human judgment and AI assistance defines modern defensive missile guidance. Communication between different systems is another area where AI plays a major role. Israel's defensive networks include radars, command centers, launch platforms, and monitoring stations. Previously, these systems had limited connectivity, causing delays and misalignment. AI-driven communication hubs now streamline everything. They act like translators, ensuring every device understands the data coming from others. When one sensor detects something, the information instantly reaches all connected systems, already organized and filtered. This shared understanding creates a unified operational picture. AI also helps prioritize messages. Instead of overwhelming operators with constant alerts, it highlights the most important ones. The system reduces noise and focuses attention where it's needed most. Another benefit is resilience. If one communication link becomes unreliable, AI automatically reroutes data through alternative paths. This keeps information flowing without interruption. Engineers describe this as a network backbone that strengthens the entire defensive structure. Again, the focus isn't aggression, it's clarity, stability, and efficiency. Good communication reduces confusion and helps teams work together more effectively. This intelligent linking of systems is one reason Israel's AI-supported platforms are known for reliability. Safety and error reduction are key reasons Israel relies on AI in its missile-related technologies. Mistakes can happen when humans face pressure fatigue or overwhelming amounts of information. AI helps prevent these issues by acting as a constant monitor. It checks data for inconsistencies, verifies sensor readings, and warns operators when something looks unusual. One important feature is the cross-validation layer. When different sensors report different readings, AI compares the values, evaluates which one is likely correct, and presents the clearest version to operators. This helps avoid decisions based on misleading data. AI also helps prevent technical malfunctions. It constantly scans the health of the system, temperature, voltage levels, signal quality, and alerts engineers before a failure occurs. This predictive maintenance reduces downtime and ensures the system works smoothly when needed. Many improvements come from machine learning models that study past incidents to understand what small warning signs looked like earlier. By learning patterns, the AI becomes better at spotting similar issues in the future. This makes the entire defensive framework safer and more dependable, showing how technology can enhance stability rather than introduce new risks. AI also helps manage large-scale coordination across Israel's defensive layers. Instead of relying solely on human teams to oversee every detail, AI organizes the flow of tasks so each part of the system works in harmony. When sensors detect activity, AI maps out which platform should respond and which should remain on standby. This prevents unnecessary overlap and ensures resources are used efficiently. Coordination models also consider timing. Some systems respond faster than others, so AI recommends the order in which each component should act. This sequencing helps maintain smooth operations and avoids delays caused by manual decision-making. Another valuable feature is simulation-based planning. Before a system reacts, AI runs quick internal simulations to evaluate possible outcomes. It then highlights the option with the highest efficiency and lowest risk. Again, operators stay in control. They simply receive better organized choices. This type of coordination also reduces the chances of technical conflicts where two systems unintentionally interfere with each other. By keeping everything synchronized, AI supports safer and more stable defensive practices. Israel's engineers often emphasize that coordination is not about strength. It's about smart management and clear structure. AI's learning capability is one of the most transformative parts of Israel's defensive technology. These systems use machine learning models that improve over time. Every real-world scenario, test, or simulation becomes additional training material. The more data the system encounters, the sharper its predictions and recommendations become. Learning models pay attention to small details, speed variations, pattern shifts, environmental behavior, and store them for future reference. This allows the system to adapt rather than depend solely on pre-programmed instructions. Israel also uses continuous training loops, meaning the AI is updated regularly with new information. Instead of waiting years for a major upgrade, the system becomes more refined every month. Another important point is ethical structure. Israel's engineers build restrictions into the AI so it doesn't act independently or make unapproved decisions. These guardrails ensure the AI remains a supportive tool. As the AI becomes more advanced, it enhances precision, reduces confusion, and improves operator awareness. This steady learning cycle is the quiet engine behind Israel's evolving missile-related technologies, showing how digital intelligence can strengthen stability through clarity rather than intensity. Looking ahead, Israel plans to expand the role of AI even further within its defensive framework. Future systems aim to provide even clearer information displays, safer guidance models, and more responsive communication links. Engineers are also exploring hybrid AI systems that combine rule-based logic with deep learning models, giving operators both predictability and adaptive intelligence. Another focus is reducing human workload by simplifying interfaces. Instead of presenting operators with dozens of screens, AI will organize everything into clean, visual dashboards that highlight only what's important. This will help teams stay focused without feeling overwhelmed. Israel is also experimenting with AI-supported testing environments where thousands of scenarios can be simulated to prepare the systems for rare situations. This improves reliability without real-world risk. Ethical limits will continue to play a major role, ensuring that AI remains under firm human oversight. The long-term goal isn't to create autonomous systems, it's to enhance safety, reduce errors, and improve information clarity. As AI evolves, Israel's defensive technologies are becoming more intelligent, more stable, and more efficient, driven by a calm and deliberate approach to digital innovation. If you found this breakdown helpful, make sure to like the video, subscribe to the channel, and let me know in the comments what topic you'd like to explore next.